Hello everybody and welcome to Lab 10, Galaxies and Clusters of Galaxies. In this lab, we'll learn about galaxies, their shape and classification, and galaxy clusters. There are two sections. First section is galaxy classification, second section is galaxy clusters. What is a galaxy? Let's start with this definition. A galaxy is a giant collection of stars. We have billions of stars in each galaxy. They have different sizes. In order to see this scale, we can start from our planet, the Earth, then we can zoom out. So our planet is a member of solar system orbiting around the sun. If we zoom out, just a single small point orbiting around the sun. If we zoom out a little more, we can see local group of stars, and our sun is a small star in this family. If we zoom out multiple times, we can see our Milky Way. In this case, we are a very small point orbiting around the Milky Way. If we zoom out a little more, we can see clusters of galaxies and superclusters of galaxies. So for example, if we look at this one, this is an elliptical galaxy. There are billions of stars here. We don't have a lot of star formation in elliptical galaxies. They are kind of a sphere or spheroid bulge of stars. We also have these galaxies. So this is in a spiral. There are spiral arms, and this one is barred spiral. Central part is not round, it's bar shape. Spiral galaxies have a lot of star formation. This one is also is a spiral galaxy. In this case, we have a smaller one. They are actually colliding here. Spiral arms are different colors. You see star formation, and this one is regular spiral or just simply spiral. Central part is round bulge of stars. We can classify these galaxies. This is called Hubble classification or Hubble tuning fork. We start from ellipticals. This is first type. They are round or sphere or bulge of stars. We also have spirals. It's self-explanatory. We have spiral arms. So for example, if you look at this one is elliptical. It goes here. This one is a spiral. This one is also spiral galaxy. They go here. But if we compare spiral galaxy, we see they have different central part. So this one is round, the other one is barred. So we can classify spirals in two subgroups. One of them is just regular spiral, or we use S. The other one is barred spiral, or SB. B stands for barred, and we use capital B. You'll see why. Now let's talk about subtypes. For ellipticals, we have E0 to E7 and numbers in between E0, E1, E2, E3, and so on. The main difference is their shape. For E0, we have a sphere. For E7, we have kind of ellipsoid. It's stretched. It's not as symmetric as E0. And all others are in between. We also have subtypes for spirals. In this case, the main difference is separation between arms. You can see one of them arms are very compact, the other arms they are very spread. First one is SA. It's very compact. We have SP, and we also have SC. It's the same for barred spirals. We have SBA. This is capital B. SBA, SBB, and SBC for the last one. Okay, if we put all together, we have the Hubble classification. And you can see why it's called Hubble tuning fork. It's like a fork. We have ellipticals on one side and spirals on the other side For spirals, we have regular spirals and barred spirals. There's a problem with classification. Problem is, depending on your location, you will see different morphology. It will look different. Let's say we have a spiral galaxy. This is face-on view, and this is edge-on view, and they will be different. For edge-on view, you see something like in line. For face-on view, you will see full spiral structure. We can move around one galaxy, but let's look at two different galaxies. One face-on galaxy, another one is edge-on. You can see for face-on, we see all spiral arms and central part, but for edge-on, it looks like a line. And it's interesting because you can see this dark line. This dark line is the dust, and the dust blocks the light. But both of them are still spiral galaxies.